All right, so we've already learned how to compute limits graphically, and now we will learn how to actually compute them analytically or using the equations. So what we discussed is limits aren't the actual value at a given point. They're the value that the function approaches as you get closer and closer to that point. But when we are calculating them analytically, we typically will just plug in the value at that point, if possible. So let's say we had, for example, the limit of as x goes to 2 of the function just x. Well, I mean, for that, we literally just plug in the value 2. And so as x goes to 2, we just plug in 2 for x, and the limit is equal to 2. It's literally that easy. Now, it does get more complex, but for the most part, and we can see that graphically too. So if we plot the function y equals x, then we can see that at x equals 2, the function value, the y value, is also equal to 2. So then it's true that the one-sided limit on the negative side and the one-sided limit on the positive side both approach 2, which, as we learned last time, that means that the two-sided limit exists and it also approaches 2. Okay. Okay, but there's a lot of different properties that we'll learn for limits that make computing them easier. And many of them are kind of intuitive. It's kind of what you would expect, at least in my opinion. So let's say you have the limit as x goes to a of function f of x plus or minus the function g of x. So two different functions. F of x could be x, g of x could be x squared, like a polynomial. Then the limit is simply, limit as x goes to a of f of x plus the limit as x goes to a g of x. Let me rearrange this. I'll put a box around it later. Okay. So that sort of makes sense, right? Like, or plus or minus, excuse me, because I said that. So basically, you can just take the limit as each one goes to a individually. But what that means in practice is you can, if this was limit as x goes to 2 of x plus x squared, then we could just literally plug in 2 for each of them. So it would be 2 plus 2 squared, so 6. Okay. The limit as x goes to a of f of x times g of x is just the limit x goes to a of f of x times the limit as x goes to a of g of x. So if we had, for example, the limit as x goes to 2 of x squared, well, that's kind of like the same thing as saying as x goes to 2 of x times x, which would mean that we could split that up into 2. And the limit of each of those is 2, so the limit of both of them is 4, which is what we saw here, that the limit of that one individually was 4. Any questions so far? Okay. Now, I will say, whenever you're computing these, the proper way to do it is for each line, continue writing the limit, and I know it gets annoying, but continue writing the limit notation in each one until you actually plug in that limit. So at this point here, I actually plugged in the limit as x goes to 2, so I no longer need it. All right. And just like with multiplication, there is a division rule as well. So the limit as x goes to a of f of x over g of x equals limit of x goes to a of f of x divided by limit as x goes to a of g of x. Okay. I won't do an example for that because it's fairly obvious, unless you want me to.
No.
You okay? Okay. There's another one. So the limit as x goes to a of c times f of x where c is a constant, is equal to c times the limit as x goes to a of f of x. So basically, a constant multiplier does not change or does not affect how we apply the limit. We can just pull it out, like factoring. And finally, the last one is actually, no, there's two more. Sorry. As x goes to a of f of x to the n power is equal to the limit as x goes to a f of x all to the n power. So an example of this would be like that same x squared problem. So we had limit as x goes to a of x squared, 2, excuse me. Well, that's the same thing as the limit x goes to 2 of x squared, which is 2 squared or 4. Okay. And last but not least, oh, by the way, for this one, n can be a fraction. So do you know what fractional exponents are?
Yeah.
Like if I had exponent 1/2.
It's like the opposite.
What do you mean?
Like you multiply by 1/2 of. Or no, it's square root.
Square root. Yeah. Okay.
Yeah.
Okay. What about a negative exponent? What would that be?
It depends on if it's even or odd, right?
So like if I had x to the -1, what would that be?
Negative x.
Not quite, actually.
-1.
It's actually
Negative x.
just 1/x.
Okay.
Actually, no. So that's the thing about exponential functions like
Yeah.
this, or any exponent.
Yeah.
No matter what the exponent is, even if it's a negative number or a fraction, it'll never result in a negative number.
That's an ACT problem right there. Something that I've just pushed so far out of my mind.
But yeah. So that's that would be one good thing to maybe review before taking that. Have you taken your ACT?
I have.
You have? Oh, okay. Well then, never mind. Okay. So the last thing is just the limit as x goes to a of c, where again c is a constant. Is just c. Because, I mean, if we think about it graphically, like, for example, if we did like y equals 2, well, that's just a horizontal line, yeah. So it will always approach the value y equals 2 because it's, yeah. I feel like it's self-explanatory, but.
Sometimes you have to explain.
Well, it's like, you know, the constant struggle of, if I under-explain it, are you going to understand, or, you know.
Yeah. Sometimes over-explaining complicates too.
Over-explaining can complicate, or
Like
you might already know it. Yeah.
Foiling, like if someone were to actually like explain what's going on in a different way than first, outside, inside, last.
Yeah. Or have you seen the Common Core way to do multiplication? Google it. Just Google it.
Right now?
No, not right
Okay.
now. Not right now. We have class.
Yes, that's right.
Okay, so let's say we have, let me pull up an example problem. That's not. Or not. Okay. So we are going to do one problem like this, and then I will not expect you to do every single problem like this because it gets very annoying, and I don't think it's necessary, but it's good to know all these properties. So what we're going to do is we're going to apply the properties to all of these, every property that we can. So first property we'd want to do is probably, actually we'll do two problems. I'll walk you through one and then you do the next one. So first property that we want to do is split this up into three different functions. So that would be using the addition property that we saw, the first one. So that would be limit as t goes to -2 of 14 minus the limit of t goes to -2 of 6t plus the limit t goes to -2 of t cubed. And then, well, for this one, we can use the property that a constant, limit of a constant is equal to itself, so that's just 14. Minus, well, the constant multiple, because we're applying all the rules, right? So the constant multiple, we pull that out. So it'd be 6 times the limit t goes to -2 t. Plus, and then we can use the power rule, the n power rule, right? So that would be the limit as t goes to -2 is t to the cube. Okay, so that would, now we can just plug it in. So the limit of t as t goes to -2 is just -2. So that'll be 6 times -2. And I'm applying the limit now, so I no longer need that notation. And also -2 here, cubed, right. So we'll have 14 plus 12 minus 8. Yeah, so what's that? 26 minus 8, 18?
Yes.
That sound right? Okay. I was genuinely asking for your confirmation.
Is it 18?
Yeah.
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 You're just seeing if I was awake.
That's what, yeah. That's what that was. Okay, let's do another example. Let's do this one. Oh my gosh, we're already out of time. Okay, no, we're not doing this one. Sorry, we're gonna.
That's okay.
We need to do one other one that I wanted to get to real quick. So it's not always possible. We're not going to apply all the rules here. Most of the time, I'd say in the majority of limits, until you get to harder stuff like at infinity and things like that, you won't be able to, you will be able to most of the time just plug in the number. But if we do that here, if we literally just plug it in, we'll have 2 squared plus 4 times 2 minus 12 over 2 squared minus 2 times 2. So on bottom, we'll get a 0, something over 0. And that is undefined, so we can't do that.
So you have to factor.
Correct, yeah. So the
It's not that bad.
the top would be 6 x plus 2.
X plus 6 and x minus 2.
X minus 2, good. That is not a 2. Okay. And on bottom, we can factor out an x. And then we'll have x minus 2. And now we can cancel.
Is there x minus 1? No. Yeah?
No, because we pull out.
That's right.
Yeah.
Sorry.
No, you're good. You're good. It's all right.
X plus 6 over x.
And now if we plug into, actually, excuse me, I broke my own rule. So we gotta rewrite the limit. Now if we plug into, we'll get 2 plus 2 over 2 equals 2. It's all 2s, all the way down. Okay, so there's that. I may give you one type of problem that we didn't specifically get to cover, but I will show you, or like in your homework, I'll put the practice, which will have the solution on how to do it.
Okay.
And yeah, that's it for today. I will see you on Tuesday.
All right. Yes.
You have a very good weekend.